Hi everyone. Is it working? Or should I? Okay, thanks. Okay, now you can hear me. So yeah, hi. I'm Krzysiek, but Chris, you can call me Chris as well. And I'm here today to tell you about how you can create spontaneous AR interactions with ARCore and instant apps. So before I start, I don't know what's doing this crackling sound. But yeah, before I start, I'm a software engineer by training. Or can anyone hear me from here? Yeah, I think that would be better. So I'm a software engineer by training, but for the past 2 years, I've been working more as a product manager in VR, AR space, so mostly working in Unity, but in the past, I've been Android developer, so that's why I'm still trying to keep looking in what's going on with Android as well. And yeah, besides I'm a sports climber, if you want to chat about that as well. And I'm also part of something called vRational, and it's quite new initiative, and we are a bunch of freelancers doing projects in VR, AR, machine learning. That's all what I will tell you about this. Okay, so how many of you know what ARCore is? Just raise a hand, yeah. Okay, pretty decent, but not all of you. So before I start, I just want to show you the video that Google released, and I think that it explains the idea. Oh, and we lost it somehow. Okay, so what you've seen, because probably all of you, I imagine, know something about augmented reality, but in the past we were doing this using markers or like displaying something on QR code or whatever. With ARCore, you can do it without markers at all, and it has 6 degrees of freedom, which means you can move around this experience. It will stay in place. It will be persistent. With new updates from Google, they even released something called AR Cloud. So those experiences can be persistent globally. So you can put some, I don't know, like an AR experience somewhere here on the wall behind you or whatever, and someone else can come and see what you already created. And it's only done using what was already on board, which means RGB camera from the phone and sensors, meaning accelerometer and gyroscope. What you also could have seen in the video, there is something which is interesting and which those AR experiences also utilized, is light estimation. So ARCore also gives you some information about how lit the environment is. Is it like dim or daylight, for instance? And you can use it to differentiate your AR experience that way. And most importantly, it tracks planes. Both horizontal and vertical ones. So you can actually put your experience on the surfaces as well. Okay, so what was the idea behind these spontaneous AR experiences? It combines ARCore and something called instant apps. Instant apps will be explained later, but just to give you an idea, that's the app that I created, and we will go through this, how I developed this sort of app. So it started from business card, my personal business card, where is a regular QR code, which redirects to my personal web page. And on this web page, I have a link, like try these spontaneous AR experiences. And what you could have seen, just briefly, like a couple of last seconds, it didn't redirected me to Google Play Store directly, but it opened already an app. So instant apps, it's something which you don't have to install from Google Play, and your users don't have to do that, but they can just try it. And this will start downloading an app. It has to be limited in size, so no more than 10 megabytes. But yes, more or less it is. So this can continue, because then instead of doing something in web, which is easy to access, but you can utilize a whole power of your device, meaning it's not JavaScript, it's still Android, and it has access to the sensors, so to like internet is obvious, but you can access, for instance, with this one, camera, camera now also you can access in browser. But there is billing, there is, you can access more about, like, there will be more, because yeah, I hardly call any other permissions, because I only used camera and internet permissions there. But there are some you can also use with these instant apps. And yes, you can see, like, you can build an experience, and in this case, it's a watch, like, the use case is, like, you come to the store, you see some sort of leaflet, and you can directly try the product with AR on your hand, for instance. So that's what I tried to do. And also, like, you can utilize the regular Android development, which is like this UI you see in this video, which redirected me to the web page now, was a regular Android XML file, rendered with regular Android XML file. So yeah, that's more or less how you can use it. So instead of, like, AR is really not well understood globally. So I think it's really good to match those two things, like instant apps and AR, because you don't have to make your users install your fancy AR app. You can just drag them somehow into the experience using other methods like QR codes or links or whatever. Oh yeah, and there is so one part was this using this sort of markers like leaflets. This is called augmented image. This is something which was possible, like, way in the past. But the other part is this regular ARCore tracking, which is like once you find a surface, you can tap, and this you just see my business sort of 3D representation of my business card. So this is this one. Okay, so now we will dive more into the code. But before you start, so if you go home and you want to start by yourself, it's best to make sure you have, like, all those installed, which means you should rather, especially when it comes to instant app, you should rather go with the newest version of Android Studio, which is 3.2. Now at the moment, maybe there is newer, but that's the one that I used like a month ago. You need to make sure you have Android emulator, all the images updated, because I saw some strange artifacts when tried working with older versions. And you can work in emulator with ARCore, but it has to be pixel image, pixel phone image, and you need to install ARCore emulator, APK, which is like this. Oh, this is here. So there is a website on the ARCore GitHub, and you can download the APK for the emulator, and then you can start working in emulator with ARCore and something called SceneForm. So SceneForm is a helper, so like helper library, which also adds additional layer on 3D, like OpenGL, like regular stuff you can render, which helped me to build all those, like easily import 3D model for the watch, render this view renderable, and all that stuff. So most important things, and I will show it all in the code, but things which were used in the demo you've seen is something called view renderable, and that's what I already explained. This is like how you can use a regular XML Android layout and render it in 3D. Model renderable, which is like you can import models, all the GLTF, all the modern formats with this one. And also you can write your own renderable, and those strange, I don't know how to even call that, like those triangles floating in air, that's something which I generated procedurally and wrote my own shader for that as well. And nodes. And nodes is the most important part, because if you want to do an AR app, the scene is in 3D, and it has to be constructed like with hierarchy. So you have nodes, and the nodes can have parents. So then there is a scene node, and then you put your stuff in the scene, having like your child nodes, and those child nodes can have also child nodes as well, children nodes. And it basically propagates all the translations, transformations of the objects you do. I will show it in code. It will make more sense in a moment. So yeah, let's jump to that. Okay. So, yeah, I think I will have to do something like this. Can you see it now? Is it okay? A bit more. Okay. Okay. So more or less with ARCore and Synform, you can work like as before. Like I don't use Kotlin. I didn't have time to dig into Kotlin more. But yeah, so this will be Java syntax most of the time, actually all of the time. So yeah, so the most important stuff is like you use whatever is already provided. So for instance, our main main features come from something called AR fragment. This is like delivered from Synform. I actually had to override it because of some issues. It's still like they're still developing. Oh, why it's stopped zooming? Okay, because they have some issues with still with the life cycle of how you can load things. But well, I will explain later if needed. So most important stuff, I think, is here, because I told you that I'm composing a scene. So what you've seen, for instance, and this code here, like particularly here, comes for this AR business card. So I have my ARCore node, which is the place where the user tapped on the plane, on something which was detected in the scene. And then basically I'm setting like it to the scene, like to the root of the scene, this place. And on this place, which is the ARCore node, I'm adding all the other stuff. And I think it's pretty easy, because like those methods used in the nodes are self-explanatory, more or less. So you can set the scale on those nodes. So whenever you import something, you can easily change the scale of the object. You obviously can set a position. So for instance, here just means like this node, particular node, which is like the right part of this floating triangles, will be set 1 meter to the right, which is vector right just initializes the 100 vector, which is like x 1 meter in x axis. And yeah, and you just basically set the parent as well. So this is now the parent of the place where the user tapped, and I add the shape that I wanted to initialize here. All the other stuff is also positioned like in the same way, more or less. Okay, so about those shapes. So first I told you about the view renderables, and view renderables, like this is something that wraps a regular Android layouts. So for instance, vRational view, this is like the middle part of this business card, which is the regular image view. There are a few things which are changed from, I think, regular layout development. Usually you have to constrain the widths or heights. So because you want your stuff, especially views in a scene, to have some sort of constraints. They have to have some sort of size. There are some defaults, but I saw that it's really unpredictable what you get if you don't set like a layout width or height. Okay, so this is one example, and obviously you can even render the web view, the whole web view, and in your AR scene. There are some problems. Maybe we will have time, so I will try to run web view in an emulator, because basically the apps really slows down. There is probably some problems with transitioning from main thread and background threads, but yeah. Okay, so this was the view renderables. So this is just you write a regular layout file and then you wrap it in the view renderable. And the other stuff is yeah, the wedge by view. That's another example which just, yeah, before I stop. So this is what I also used. And here, more importantly, you can program your views as regular. So you just, like connect to the view with click listener, and then you can launch whatever you need from your Android app as a callback. And it's already built in. So all the communication between like the screen, so what the user does on the screen with those view renderables in 3D are already programmed. Okay, so another thing that I explained also to you that you can use to build your AR scene is this model renderable, and it loads like the model. And those models, they are not exactly the models that you just put OBJ or whatever file. You have to write special file for that in the SFA format. I will not go much into details, but basically you create those connections. So you add the mesh. This is something which you can see, FBX or OBJ file. This is the regular model, the mesh of the model. But you have to configure all the other stuff, which the most important part, I think, is the material part. Because you still have to connect it with the properties, to your textures, to your normal maps. And since Google, in SceneForm, they use something called Google Filament. This is physically based rendering. So you can actually use all those normal maps, height maps, and it provides a really decent effect. So I think the most important part, which is not maybe clear to all of you, physical-based rendering means you actually can simulate the physical properties of the materials. So you can create like this sort of glossiness effect on them. You can create this sort of roughness effect. So if you import a rock, it can really be very, very matte and like rocky. I don't know how to even explain that better. So more importantly, once you import that, and you can see that there is already, it's also providing, the SceneForm provides a trick for this glossiness. So they import actually this sort of 360 degrees image as well. So those reflections, they are always the same. So, but people, when they try your experience, they will think that it actually exists because it reflects something. They will not be able to notice that it's not the environment they are in currently. But, well, probably some will, but not all of them. And it provides this really physical feeling of the AR objects. So yeah, so this is what you have to configure. And I will show you one more example because since we are here, or maybe not. Okay, I will come back to this later. And obviously, they provide this sort of nice viewer, which we used to explain that. Okay, coming back to here. We'll not go once again into details, but more or less like positioning the objects is the same. The only difference here is I use something called transformable node, which actually also there is a built-in scale and translation operations. So once you import a model and add it into transferable node, then the user can actually later on scale it a bit, scale it up or down, or like put it anywhere else in the scene. So yeah, once again, it's pretty like easy. Once you go to the AR SceneForm documentation, then you will find it all of this as well. Okay, promise one more thing. This sort of procedurally generated shape. Yes. So I have something called vRational shape. This is like those triangles that I told you about. So there is a way, and this model renderable builder, it was once used to import this sort of models, but it can also be used to import something called renderable definition. Once again, there is an APK for that, but basically you create a mesh on the fly with all those vertices and triangles by yourself. So obviously I generate some random like vertex in the scene, and the other part I have to create connections. So in order for any actually rendering engine to render anything, you need to at least have one triangle. So that's why here like is the code which just generates randomly triangles on those vertices. And yes, and then you just apply those vertices as submeshes, apply vertices which I generated, and this basically creates this sort of mesh. I cannot show it to you because like this viewer doesn't support like on-the-fly generation of something like this, but we will see it in a bit in emulator. Actually, we can already start launching it. Was it here? Yeah. Okay. Okay, so this was the model renderables. We covered the nodes. And yeah, so before I even launch it in emulator, one more thing. which is this custom matte. So I have something. Oh, I will actually, I can demonstrate it to you because I saw that this is applied somewhere. I think here, not. Where is it? Here. I don't know why it is. This is here. So this is custom SFB. This is actually, this is a hack which I used. This actually renders my own material, and this material I showed you here. And just to show you that it works, I will change one simple thing, and it should start pulsing. I think it was here. It has to compile. Yeah. Okay. So what I actually, this sort of procedurally generated shapes. I don't know if you can see it well. Okay, sorry for that because I forgot to zoom in. So yeah, so as I told you, you can generate procedurally geometry in ARCore, and you can also procedurally generate your own materials. And this is material which utilizes the same filament syntax. They have some sort of, I don't even know. They created their own format which is similar to GLSL, but they have additional properties. But basically, you have two important stuff, which is vertex shaders and fragment shaders. And in 3D rendering, you use vertex shaders are applied for every vertex in the model. So that's what comes first. And fragment shaders are applied on each pixel, each rendered pixel of a triangle. So more or less, this is what's important to note here, that it's better to write stuff in vertex shader because they have to run much less than fragment shaders. So that's what I wanted to do, because I wanted to create this sort of living structure of those triangles. It would be possible to write it in code, in regular Java, but it wouldn't be performant enough. So that's why I wanted to do actually create a vertex shader for this one. And this is just a simple code and simple hack actually, which translate the normals and use them to change the world position of the vertex using time and sine function, obviously. So it's just basically goes like this all the time, and it can be applied on any model, and that's what I use on those cloud of triangles as well. Okay, so this is stuff which was actually, you will not find it probably anywhere, because I spent some time in trying to create this vertex shader and actually how you can apply it dynamically. But yes, okay. So finally, let's go to the emulator, because emulator has some pretty decent features. So what once you install this ARCore emulator, so they will be emulating you a scene. The whole scene, there is somewhere, I saw it once. Okay, yeah, you can make it a little bit bigger, slightly better. And yeah, and you can navigate on this scene using your keyboard and mouse. And yeah, what you see here, this is already, AR app working. So the scene form SDK provides you with a fragment, which is whenever it detects some sort of plane, it will display those dots, and you can click it. And so this was the tap interaction that I told you that created this anchor node, and all the scene was propagated then. So this is what you get. And also you see those strange triangles which I generated using this sort of shader that I have here as well. And this gives you this nice effect. That's what I more or less wanted to have. And yeah, so this is one part of this app. The other part which I told you about is I use those augmented images, which are also provided by are they part of ARCore or a scene form? Oh, well, doesn't matter. So you can, using this emulator, you can actually put in this virtual scene those images that you want to test. And obviously you can even okay, I will show it to you probably better here. So you can obviously change the size of there as well, because probably you want to test it as close to reality as possible. So for instance, if you really want to create some sort of poster on which you will create your AR experiences, you can actually set a proper size of this poster in the scene as well. and try to see from how far it will be recognized, or you can more or less use this emulator to do that. And I'm using not this particular marker at the moment, I'm using this one. So hopefully, but this, oh, the problem with markers, I'm already jumping ahead. Yeah, but it's recognized. So once it detects this sort of augmented image, it also like runs the other code, and then you have this watch. And about transformable node, which I explained to you, so that's what you get using transformable node. So you can change the position of your object, you can scale it as well. So that's what the user will be able to do. And promised on-click listener that was connected. Once I click this, it opens the intent to browser with this sort of link to shop. So yes, so that covers that. I don't know if, well, maybe we don't have much time, so I will not change anything and try to break things and show you the differences, but well, we still have some things to cover. So I hope you liked it. I think so before I tried it once already, this live coding, and last time it was much worse. Actually, it didn't work for a moment, so hopefully all worked now. Okay, yes, so more about this physical based rendering. So just to give you some idea, so those are the properties you can use. So in regular shaders, you would just probably only experiment with colors. So more or less they will look the same, but they will have different colors. With those sort of other properties, you can actually make two things look different. So you can create one glass ball, and you can create very rocky thing with this sort of roughness, for instance, plus this sort of height map once you import it to the model. And yes, so this is about physical based rendering. This was already covered. I already told you about those differences, like properties that they created, this sort of, that's their format that they are using. Properties you have to define for vertex and fragment shader code. And this was already covered. Okay, a little bit about augmented images, because I was worried that it will not work. Because I use my own augmented image, which is like a back of my business card. And if you use like something like a poster, which is really, I don't know, like it has some sort of a very big and distinguishable features, then you can create like, even you can create something like this. Probably not with scene form. This is probably done with Unity. But just to give you an idea, you can have a marker, and then you can run an experience not only on top of it, but you can actually change the whole marker, the augmented image, into some sort of container for your AR experience, so creating this sort of fake hole in the wall. And why I'm telling you about this? Because this particular image, once you use this provided tool called ARCore image, once I evaluated it, it gave me 5%. The other marker which you have seen, for instance, like this globe in the virtual scene, gives like 95% of accuracy of recognition. Which means actually this particular marker is not very well for creating AR experiences, but still I wanted to like show you, and I just had a business card on me to use it. So yeah, still it works, but if I tried to use the other side of my business card, it gave me zero, and actually it never worked in my AR experience to try like to recognize my front face of my business card. So hopefully you have this sort of ARCore image command, and you can use it to evaluate images. And you also need to build your database, because ARCore will not match with particular images like PNG files or whatever. It will find those features in your image, and then once the ARCore runs, it will also find those features and match features to features. And features it's like a descriptor of what's in the scene. It's like I don't know what kind of operation they use, but it just basically creates some sort of constraint correlation between colors, between other distinct features in the neighborhood. And if you inspect your file later, and this is, I think, the most important part, then you can find the name which augmented image will use to identify your marker. So this is this cardback PNG. And this is what you use actually to create this particular experience for this particular augmented image. Okay, this was already covered. I actually jumped, yeah, I already told a lot you. So that's what I wanted to show you, that you can configure those augmented images in emulator. And there is a simple code to load the database. It just basically, they also have helper methods for that, so not much has to be done. And you just have to like configure it in the session beforehand. Oh yeah, I actually didn't explain. But the hard part, which you will not find in the documentation, is where actually you can initialize the database, augmented image database. And it has to be initialized once the scene form creates the session, which there is no callback for that, actually. And that's why I used my own custom AR fragment, because then you can override one get session configuration function, and then whether you can actually, that's the best place to load the database, because you don't want to load it on every resum or whatever. You would rather just load it once. And yeah, like this is a code. I haven't shown it to you. Oh yeah, actually, that's my bad. So if on update, so in every frame of the render scene, you have to do this particular. So you have to grab the reference to the frame from the. Oh, why it's broken? You have to find the reference to the frame, and using this frame, you can check for the updatable trackables. And those are how you get the reference to those augmented images markers. And important stuff here, which I told you already, you can use this sort of name that usually is the same name of your file to basically build your AR experience on top of it. So this is like a regular code. I use this watch node, which was this model renderable, and I set the anchor this time not to like this time you from augmented image you guess the anchor you can use to position properly your experience. So it will actually recognize if it's on vertical or horizontal. This code, this particular code, will put it in the proper orientation as well. Okay. Loading the database. Oh, I'm going back. So instant apps. So just to show you what are instance apps and what's important, like here, I think we'll finish in a bit. There is only one game which I found which actually utilizes instant apps, but I think that's a really good use case for instant apps games, which, like especially me, I don't like playing games for more than maybe an hour. And usually I look, when I'm bored at waiting on the bus, I'm trying to find some sort of a game or on the airport. And actually, that's the first time I played Clash Royale, thanks to these instant apps. And yes, so you can actually, you saw that I just tried try now, like click the try now button, and it's just redirected me to to this page which was downloading the Clash Royale. Once it downloaded, I am able to play partially the partial, not a full version of Clash Royale. So this will actually be looped. So I will play this one game, but this is like in a training mode of theirs. So you will more or less just play all the same stuff. That's just once you're bored, you will not go into much more levels, but you will try the experience. Obviously, you have install now options. I think that's what they had to like change in their codes, like to display this install now feature only if it's an instant app. But then you can, obviously from there you can directly download the app as well. So if your user is attracted, then he will download the app that way. And I was very optimistic once I saw that, because I think, oh, that's cool, really, making an instant app to display your, to create your sort of game or whatever, to promote it anywhere. And yeah, it's pretty easy. So in the code, you need to create another flavor. You need to make sure that your instant version has a lower version code than the full version of your app. You need to add to the manifest this model, this instant równa się true. That's the most important part. And you need to use those Android app bundles. Actually, I'm quite surprised that no one covers on this DevFest the Android app bundles, but more or less, Android app bundles are they create different variants of your APKs depending on your device architectures, on your densities, configurations, all that stuff. And the user doesn't download everything, but just that's what's needed for his or her particular device. And you generate that Android app bundle. You need to set up every key store passwords already, because you will be signing it. And that's how I felt later, because this part, like this was a brief to create a configuration files for that. But the hard part was you need to, in order to test it actually on any, either in emulator or on your device properly, you have to upload it to at least beta testing. So obviously, even if you want to launch beta testing, you have to provide like the basic informations, basic images to the Google Play, go through this sort of, how was it called, this privacy and terms and conditions, all that stuff. Put your pricing, and once you're done with your configuring, and it was very, very painful for me because I don't have those assets. I just wanted to create an app. I had to fake the banners, the icons, and all that stuff. I was able to run this sort of instant app version for beta, and that's what I saw in the Google Play then. And this is this magic button, try now. That's the only way you can get this try now button in your code. So you need to upload your APK to at least beta release. And yes, you will see, usually currently instant apps are still in beta. So your users, they have to agree that they will be using something called instant apps. But yeah, then there you will see this progress of downloading the app. And even in emulator, it will work. So you will be able to test this process in emulator. Obviously, one trick part is you need to install Google Play package to your emulator. So not all images have this supports that. And yeah, that's the previous code, like when I was still developing it. OK, I think that's for now. OK, current limitations. As I told, you have to limit your instant app. For apps, they say that it's only 4 megabytes. For games, it's up to 10 megabytes. And it also depends whether it's a basic and enhanced. Basic means it will run from Google Play or from website banners, so you can redirect to Google Play directly. But they also, with enhanced, they state that you can actually launch instant app from NFC marker or from like some sort of RFE tags, whatever. They have some sort of listed it on the web page, and those are permissions you can use. So obviously you cannot create instant apps that uses Bluetooth. So you cannot create instant apps for some sort of customer's headphones. It will not work. You can use camera, you can use location, GPS, and you can use network. I think that's the most important features. And yeah, this is still beta. So I think if you really want to publish your app to the App Store, you have to go through their form, and they have to accept you in order for your apps currently to actually be shown in the Google Play. And yes, that's all. So final remarks. That's my personal one. Don't take it seriously. So really, I think using ARCore and SceneForm for creating AR is not a good thing. I think it's better to use a fully featured engine like Unity, because if you really want to create something simple like displaying a model or I don't know, even probably only displaying sort of simple models, then ARCore and SceneForm is okay. But if you want to create a game, you have to have physics, you have to have collisions, proper collisions, all that stuff. SceneForm or ARCore doesn't cover that. So you'll have to write it from scratch or integrate some third-party library. If you go with Unity, you can actually use Unity. They have a part in the documentation where they explain how you can use Unity and Instant App together. I never tried it, but because I know that Unity, once compiled, already has 7 megabytes at least, which is like doesn't have much room. You don't have much room to actually create anything, to add models or whatever. You can download them in the background. So once your instant apps, you can obviously add some additional models as well on the fly. But well, it kind of breaks an experience also. And that's another personal of my remarks. I'm not like, and that's what I would also try to tell you, that it's not anymore about VR, AR, or like one particular technology. I think it's more about combining them together. And that's what I'm particularly interested in, on how you can utilize, for instance, AR and machine learning to create some sort of experiences. It wasn't used in this particular example, but there are other projects which I'm working on, which try to combine other technologies. And what I saw, and that's what was hard for me, especially as not anymore an Android developer. There are so many amazing SDKs from Google now. So you have this Cloud Vision, you have instant apps, you have ARCore, SceneForm. I think the best apps now can be created if they are combined together. So you can probably utilize Cloud Vision API to create instant app and create sort of AR experience, not on markers, but by detecting objects. So by detecting MacBook Pro using Cloud Vision, for instance, and then putting some sort of AR experience on top of it. Yeah, and that's all. So if you are interested in not only VR, AR, but also machine learning or robotics, just shoot me an email or find me during the break.